Today we're going to talk about relations. A relation is the elements in one set that are linked to elements in a second set. We typically show this type of relation as or using what we call a mapping. So here's a mapping of some set A to some set B. And we're going to put in values in this set from A, and here's values in set B. What we're going to do is show that when I have the number 1, I get out a number 5. I put it through some equation, or we typically call it a function. So I put the number 1 inside some function, it spits out the number 1. I put in the number 2 inside the same function, it spits out the number 5. I put in the number 3 inside the function, it spits out the number 6. So these are the function. What we really then end up with are a set of coordinates that, for example, are in the form 1, 4. What else can we have? We have 2, 5. And we have 3, 6. So here are the points that we end up with. Each one of these points have an x value and a y value. Or they have an input and an output. They also have what we call a domain and a range. Now, the domain just simply says what are all the x values. So if I look at the points that we just wrote down, we see the number 1, 2, and 3 are elements of my domain, where the value 4, 5, and 6 are values that are in my range. So I can look at the set of points and determine what the domain and range of the set of points are. Okay, here's a relation written as a set of points. So, of course, we could write these points on a coordinate plane if we chose to, but for right now, what we're going to do is just look at these points and determine what their domain and range are. So, we said that the domain represents all the values on the x-axis, or all the x-coordinates. So let's underline all the values in our domain blue. Okay? Oops, sorry. So the domain are the values 3, or -3, -2, -1, 0, 1, and 2. So these are the values in my domain, which are the x-coordinates. So in blue, or in red, let's underline all the values in my range. So the range are all 0, 2, 4, 1, -2, and 1. So those represent my domain and my ranges. Okay, next, we're given an example such that the graph is given to us. So this time we don't see every exact point on the graph, but they still want to know what is the domain and what is the range. So an easy way for me to figure this out is the domain represents all the values on the x-axis. So if I take a line, if I start at 0 at the origin, the question then becomes, can I draw a line from that point on the x-axis at 0 and still touch the graph? So if at 0 I can touch the graph. I go to another point like 1. Can I draw a line from the x-axis straight to my graph? And again, yes. Let's pick a number like 10. So, can I draw a point from 10 up to my graph? In this case, yes. So I can choose to either go up or down. As long as I can touch the graph from that point, I could go all the way to infinity and still be able to touch my graph. So far, I can touch my graph all the way to positive infinity. Let's look at the negative side. So if I chose 1, I can draw a line -1. I can draw a line down to my graph. If I go over here to, let's say, 5, I can be at 5 and draw a line up. At 100, I could draw a line up all the way to negative infinity. I can draw a line up to my graph. So anywhere on the x-axis, I can draw a line up to my graph from positive infinity to negative infinity. This means that my domain is all real numbers. So that means any number on the x-axis will be in my domain. So whether it's 1 or 200.3, it's going to be in my domain. The number pi, e, all those values are also on the domain. Now, the range is a little bit different this time. The range this time is not going to be all real numbers. So, sorry, let me back it up here. And we notice that the range, I'm going to put in blue. Well, let's pick a different orange. I'm going to start at 0 on my y-axis this time. As long as I can be on the y-axis and touch the graph with this orange line, then again, it's in my domain. So here on the graph, I can draw a horizontal line and touch my graph. Here, I can touch my graph all the way to positive infinity. I'll be able to touch my graph. However, on the below the x-axis, if I choose a y value here at, let's say, -1, I might be able to touch the graph. But the second I get to where this vertex point is, let's say the vertex is at, -5. So that represents that mark. What that's saying is the second I get to -5, then after that point, I will no longer be able to touch the graph. So what it's saying is that these points are not in my range. So my range then is only from -5 all the way up to positive infinity. So we can use interval notation to represent that. So the range is from x is between -5 and infinity. I guess technically you can't equal infinity, so let's erase that. Okay, so we saw that our domain was all real numbers. Let's write that down again. The domain is all real numbers, and the range are all the values between -5 and 8. Okay, let's try another one. Let's go to the next slide. Alright. In this one, we have a graph that looks like this. And let's say that this point is at -3. So what I notice is that anywhere on the x-axis from -3 to positive infinity, I can have values in my domain. But my range this time would be all real numbers. So my domain is everything between -3 to positive infinity. My range is all real numbers. Because on the y-axis, I can take my line, and no matter what, I'll be able to draw a horizontal line to the graph. But if on the x-axis, I can only touch the graph at -3 all the way to positive infinity. The second I get to the left side of -3, I will no longer be able to touch my graph. The last thing we're going to look at, or the last type of example we're going to look at, is the idea of what the domain and range is of a equation. Let's say we're given the equation y is equal to 3x plus 5. To determine the domain and range of an equation. So what this is asking us is, what number can I put in here and get an answer? So if I plug in values, I can create a table if I choose to. Let's pick the number -3, 0, and +4. And we'll look and see what y values we get. So as I put x values into the equation, you see that I'll get, substituting in -3, I'll get a -4 as a result. Substitute in 0, I get +5. And then substitute in 4, I'll get 17. So here we notice that I could pick either a positive number, I can pick 0, I could even put decimals in here if I chose to. I'm going to get a y value. So the domain in this case is all real numbers. And I'm going to use the symbol this to represent all real numbers. The range is asking the question, well, what values of y am I going to get out? So the values of y that I get out are also going to be any number. I'm going to get numbers from positive infinity to all the way to negative infinity. So again, I'm going to get all real numbers. So the solutions can either be positive or negative, and the values that I put in are also going to be positive or negative. Okay? Go ahead and attempt the classwork.